Okay, so let me start with syllabus. You already have the syllabus on your Blackboard, so let me show you the main aspect of it. So the outline is the following. I need to discuss what to expect from the lab, what is it about, the learning outcomes, and I need to discuss the main objectives, because you're going to be surprised a bit. When do we meet and where? The grading system and how you will be graded with lab reports. What are lab reports and how can you start a lab report? I'm going to go fast. Please stop me if you believe you have a question. For this lab, Physics 302, you will cover a lot of mechanics. By mechanics, I mean projectile motion, motion on an incline, centripetal force, momentum, and collision. You will do some rotation as well, which is also mechanics. You will do simple harmonic motion, which falls under waves and vibrations. You will do buoyancy in a liquid. Waves in an air column is basically resonance. I'm sure you did resonance in high school anyway. And the final two experiments are heat. One related to linear expansion. You know, when you heat an object, it will expand. And specific heat capacity is when you have two objects at a different temperature, you put them together, you have T final, Q1 is equal to minus Q2, MC delta T, MC delta T. Probably you did that in chemistry in high school. Probably, I don't know. I've never taught chemistry in high school, but I know they don't do it in physics unless you're IB. So C is the specific heat capacity. We're gonna do this, all right? Now the learning outcomes, this is what you can find in your syllabus. The most important thing I want you to know is teamwork is very important, and we cannot do a lot of teamwork while online. Yes, you can do your lab report with someone. I'm going to discuss this at the end. But what we meant by teamwork is working on a bench, communicating, agreeing or not agreeing on something. This is key. Also, you need to know that, yes, physics is a very important objective of the lab, but it's not the main, which means the most important objective is data analysis. You will be surprised, yes, you will be frustrated as well, because you will not gonna like data analysis for many reasons. One, it's new. Probably you've never done data analysis before. Two, it's a bit complicated. And three, you will have a lot of confidence. You will say, I'm good in physics. I don't need data analysis. You will not listen. You will not do the work. And you will not do well in the midterm. And you will be angry and you would say, Ma miss, I'm good at physics. How come I need data analysis? ما بفهم data analysis. ما بدي data analysis. Bro, you have to understand, physics lab is about data analysis. It's not about physics, okay? That's why you have the course for the physics and the physics lab for data analysis. So our session today is super important. I decided to divide it into two parts because I want to tackle each and every item very slowly, all right? Okay, so when do we meet and where? I want you to be aware that we are 6 sections and you are this one, the third one. We are 2 instructors. We usually meet in Zachem Engineering Hall 604 if we are on campus. The session is usually 3 hours long. Briefing, you do the experiment, take data, do the lab report on Scratch, and then you leave. Since we're doing online so far until I don't know when, allocate around 90 minutes. We usually finish between 60 and 90 minutes. It's gonna be all explanation needed, and you do the lab report over the week. So the 3 hours given here on the banner are the whole weekly work that you should do, all right? Hopefully we don't go beyond, a lot beyond 3 hours a week. As you can see, the course is 1 credit. I took a screenshot of the Monday lab. I forgot to update it to Tuesday. I know you are a Tuesday section. It's important to know that for the Tuesday section, week 2 or 3, whatever you want to call it, is off because you know next Tuesday is off. Anyway, so Monday will be ahead of us, but we will find a way to reach the final exam done with all 10 experiments. So yes, we have 10 experiments. We have a midterm. You see the midterm? The midterm will cover, I think, the first 4, 1, 2, 3, 4 experiments. Today, February 2, we're doing introduction to error analysis, by the way. The final exam will cover the remaining lab reports, experiments, 5 to 10. So no, the final exam is not cumulative. And the difference between a midterm and a final exam is that the midterm is a mini exam and the final exam is an actual exam, because we didn't want you to reach the final exam with no prior trial. So it's like, it's a time for you to try, okay? I'm gonna keep the chats here just in case. All right, what else? We will always meet following this room, the room you are at now. I know that for a fact we have office hours as per the syllabus. I'm not gonna follow those office hours because I think it's ridiculous for me to wait in my virtual office in case somebody has a question. Office hours are actually good if you are on campus. I thought it's probably more beneficial and more efficient if we can meet every single day and every single time you need me. All right? You just have to ask for an appointment and we can meet every single day. Do you think it's better? Yes? So daily meetings are better than weekly office hours? What do you think? Yeah, you can nod. No need to unmute. Yes, all right. So yeah, and you can see my email. Please email me anytime you want or reply to my previous emails. All right, now the grading system. You have a midterm and a final exam equally distributed, 25%, 25%. The lab reports that are actually 10 lab reports. Romy, what do you mean by probably? You mean probably it's gonna be better for you? It's as if you don't agree, you don't like it.
No, it's probably better.
Okay.
It's probably better.
Right, we can try. You don't like it, we can keep something fixed. I know office hours could be interesting because probably you come and meet many students and you listen to everybody else's questions. Yeah, maybe that's the only difference. However, if you're alone, you ask alone. If you want, you can throw your questions on the chat, on the WhatsApp. I suppose everybody is aware of our group now, so everybody can listen to your question, maybe. So I was discussing lab reports. You will have 10 lab reports, each of which, or all of them will go under the 50%. And yes, you can have one partner, not more, and you can work alone. So having a partner is actually optional. It's not mandatory. And basically we do understand online is not really teamwork, so it's only if you need to discuss stuff with someone. But whatever you do, make sure you save the lab report, one copy for you and one copy for your partner, because nobody knows where your partner will end up. All right, probably the partner will drop the course, will travel, so make sure you have a copy for yourself. Now the lab report, how does it look like? You will be given a manual made of the different experiments. This is a piece of a manual. Let me show you. You will see the objectives, you will see the experiments, the theory, the equipment actually, and eventually you will see the procedure, step by step, what to do. I will be doing the experiments recorded. I know this is awkward and probably you would hate this, but so far we did not find any better alternative. This is the lab report. The good news is that you have to fill in the blanks and that's it. So you are not required to write your own lab report. You see, I know previously in high school you used to write your own lab report probably. And in chemistry lab, if you're taking chemistry lab, you write your own lab report. For physics, we just want you to fill in a template. The template will be given to you as doc and PDF. PDF is nice to view from any tablet or smartphone. And in PDF, we are sure the tables, the graphs are not mixed up. The doc version is nice because you can edit easily. It depends on which app you actually use. So it's up to you to pick what you want, but please take only the lab report you want. Don't submit the whole manual, all right? So if you want lab report 1, delete everything, save as only the lab reports you need, fill in the blanks, do your graphs, make sure you include everything in one document your graphs, your figures, your pictures probably, your tables, your calculations, and yes, you have to type your own equations. I know you would hate that, but yes, you will get used to it. Remember, this is an official lab report. Yes, it's gonna be given to me, but eventually you should train yourself to write a lab report to be shared with your boss, to be shared with your patient, to be shared with your customer. I don't know. So it has to be official, like Times New Roman, font 12. I'm gonna, this is basically not graded, but I'm gonna give you a lot of remarks on that. Not to be silly, but you need to end up knowing how to write an official lab report. When you finish the whole thing, you convert to PDF and you submit on Blackboard. Why converting to PDF? You don't have to convert to PDF. But if you don't, sometimes your graphs will not look good to me. I'm on the other side of Blackboard, and you know Blackboard may not be user friendly on doc. So if you convert to PDF first, you make sure your lab report is gonna look exactly how you see it on your screen. Okay, and this is important. This is how your Blackboard will look like. You will see the experiment. If you click on this one, probably you will see a recording of myself doing the experiment. This is a doc version of the lab report. I'm planning not to give you each and single lab report, probably the whole manual at the beginning of the semester. We may need a whiteboard or probably a PowerPoint presentation like this one. The recorded session, like now I'm recording the session. I'm recording it for the students who are missing and for yourself if you want to watch it again. Probably you want to watch bits and pieces of it. And there's something called submit here. If you click on this icon, you can upload your lab report. Okay, and I can see it, I can grade it on this one. So this icon is actually an assignment. Okay, and I can add anything I want under each and every chapter. Do you have any question? So let's say you're working with a partner. Let's say, let me see your names. Let's say Maria and Kausar are working together. So you put the date and you put under names Maria and Kausar. Kausar will submit her work. Maria will also submit the same file on her own Blackboard. I will go and see that both students did submit the work. I will grade one. When I see two names, I will give you same comments and same grade eventually. All right. So I know it sounds ridiculous to upload twice, but it's better for you to have your own profile. And don't worry, when I see both names, I'm not going to repeat the correction twice. Cool? Any questions? All right, now for the lab reports, these are screenshots of a video for experiment for the acceleration on an incline. I was doing the video, I was using my phone, and I don't have a editing team working with me. So do not expect very nice YouTube videos. It's basically something homemade with my very old phone. So, and if you believe it's not actually clear, I can definitely explain it more, okay? So this is me trying my best to do an experiment and make it look as exciting as it is on campus. And I'm sorry if it's not great. Yes. So this is for the syllabus, we're done. If you have no questions, we can start data analysis. I'm gonna share this with you. We can edit as well. So how about I save as? And since you are section number 3, I can save it as data analysis 3. So I can share whatever edit we do. All right. So outline. We're gonna cover 1, 2, 3, 4. We still have to add item 5 and 6 that I want to do later. I'm not in a hurry to mess up your life. Let's focus on those 4. And then if you guys are okay, we can move deeper into graph skills. Okay, can we partner up with people from different sections, Chloe? So Chloe, I don't see why not, but be careful because other sections, at least make sure the same instructor is gonna grade you, because it's gonna be really confusing if you partner up with a section given by another instructor. Probably we don't follow the same methodology, the same grading, although we try, and the same explanation. If you want to pick somebody from another section and it's not on the same day, be careful. Sometimes the Monday section will be ahead of us. Chloe. So probably you decide to do projectile motion with somebody from Monday section, and you will be surprised that they did it already. You see? So be careful with that. All right? If they can wait for you, I don't know, or at least partner up with someone from Tuesday section. All right? Because Tuesday and Monday will not gonna go in parallel. All right? Keep that in mind. Personally, I don't mind, and I don't see why not. Probably it's a good thing because we will be given two different live sessions, and probably I would forget to say something to you, or probably I will add something to them, because these are two separate live sessions and I'm human. Significant figures, if you took the Lebanese curriculum, maybe you've never heard of them. For the French curriculum, they do some of significant figures. Measurements, this would deal with how to do measurements and how to differentiate between measuring tools and discuss the uncertainty on measuring tools. Averages, why do we do averages? And if we ever do averages, how do we find the uncertainty on an average? And eventually, if you will ever be asked to calculate a value, how do you round it? And what is the uncertainty on a calculated value? So we have 4 items to cover for today. All right, so let me start with significant figures. So far, especially if you are in the Lebanese curriculum, and I'm not blaming you, so far, any number given to you is mathematical. Since the day you were born, math, math, math. We don't think a lot of science in our community. And probably until now, that you will look at those numbers to be measurements and not only mathematical values. According to the calculator or any math instructor, 500 or 500.0 will be the same exact thing. But if you talk to any scientist, 500 and 500.0 would give you two separate ideas, two different measurements, giving you two different information. Anyone can tell me why, or if you can agree with me or not? Anyone? What's the difference between 500 and 500.0? You can try, even if your answer is wrong, it's okay.
The significant figures are significant figures.
Okay, significant figures.
But 500.0 has 4 significant figures.
Yes, that's true.
Also, that means we have an uncertainty on the 0 after the decimal point.
Okay, so far you're very technical to me. So that's Chinese. What do you mean by all this? You said significant figures, you said zeros and uncertainty. But what's different?
That gives us the more precise than the one who gave us the 500 because they went into decimals.
Exactly. And I can see in this chat, somebody wrote 500.0 is more precise. So if I tell you I'm going to give you 500.0, I cannot give you 400. You see, 500.0 means it can fluctuate between 500.1 and 499.9. But if I ever say $500, this one, I can give you 400 or 600. You see, if a big range of fluctuation could happen. And same for the other ones. All right, now the rules. How can we count the number of significant figures? Yes, I'm recording, Marilyn. And you can ask me questions and yes. So let me go back to the slide. Let me discuss a bit the different zeros. First of all, the non-zero digits, like 8, 3, and 5, we always count them. They are important information. The trailing zero, or the zero on the right side, it is counted only if you have a decimal. If you don't have a decimal, like 500, they're trailing, yes, with no decimal, you don't count them. In between zeros, they mean in between non-digits, is also counted. I cannot remove it. Leading zeros, so this is counted. Leading zeros are not counted because I can simply replace them with times 10 to the power of -3, for example. All right? So if you ever can replace the zeros by a power of 10, it means they are there to give you the order of magnitude, and they're not there to give you any information about precision. All right? And you can read the rules here. Let us try now to pick somebody like Rita. Rita, I need your help, and it's okay if you do mistakes. Let's simply try to count which digits are significant. So Rita, how many significant figures do you have for the first value? Probably Rita. Oh, Rita, 3 significant figures. I just show you in the chat. The next one, Rita, is how many? Also 3. And the next one? 2. So she's been counting this 0, but not this one. What about this one, Rita? 1. How many significant figures is that? 4. Thank you so much. This one is how many? 1. And this one is how many? 4. Awesome. Please speak up if you don't agree or if you have questions. So the zeros for the 500s are trailing zeros, yes, but we don't have a decimal point. We don't count them. We can simply write 5 times 10 to the 2. That's why. By the way, under no condition you give a value with no unit. Please be careful. And if you're sure it has no unit because it's a coefficient or anything else, write no unit, okay, just to make a point. We have another example we can do. Probably I can ask Dalal if she's with us to try those out. Let me zoom in a bit because the decimal point is not visible. Dalal, can you tell me quickly how many sig fig for each?
The first one has 5 significant figures.
I agree.
The second one has 4.
I agree.
The third has 6.
Right, be careful. This is a comma and not a decimal. A comma means 1,000. So how many sig figs do you
Okay.
have? So this would give you a 5 because this is 100,890. So this 0 is a trailing 0. You don't count it. I mean trailing 0 with no decimal. You don't count it. Okay. So 5 sig figs for this one.
Okay.
What about this one?
3.
3. What about this one?
2.
And what about this one?
Also 2.
Also 2. All right. I'm going to give you this to try again at home. I know it sounds so simple. So this is one of the assignments you have. By the way, this is not graded. Is it optional? Let's say it's not optional. You have to do it. But yes, it's not graded. Just for us to practice quickly those ideas. Now 2 measurements. I'm going to ask who's next? Jana. Jana, I'm sure you used a measuring tool this morning. Can you give me anything you used? Any measuring tool you used this morning, Jana?
A ruler.
كلهم بيقولوا ruler. Seriously, did you use a ruler to measure something? I did not see a ruler
No.
today. Okay, so tell me the truth. What did you use today to measure?
Probably like a weight balance.
Okay, so let me call it a bathroom scale. Yes, we all use a bathroom scale every morning, probably. Anything else you use to measure? You don't use measuring tools at home. I'm sure you do. Probably you got used to them. I used a spoon for my coffee.
She was baking, so she used the
Cup?
The small, yeah, not the cups.
The measuring tools, those spoons, different spoons. Okay, let me add a cup because a cup is interesting. Okay, you can say a beaker. You can say anything you want. I used the thermometer. I went by car and I looked at the temperature. Anything else? I'm sure you use a watch or a stopwatch because you have classes. You need to check the time. All right. I want you now, Jana, to tell me the difference between a digital measuring tool. Yes, I'm checking the chats. What's the difference between a digital? Hello, Marilyn. I'm glad. Oh, all right. I'm so sorry. I thought Marilyn just joined us because the chat scrolled down. That's ridiculous. All right. So digital measuring tool and analog measuring tool. What's the difference? Back to you, Jana.
The digital measuring tool, it measures it by itself, while the analog, you should measure it yourself.
Okay, it's a good way to approach it. Yes, it's not a great definition though. Can you try to give a definition? Can I say digital has a screen, for example?
Yes, that's what I meant. It has technology involved in it.
Okay, and analog, no screen.
Yes.
All right, let's see. The bathroom scale, is it digital or analog?
It's digital.
Could be analog though, right? If it has a needle.
Yeah, the needle.
Yeah, what about the cup?
The cup is analog.
Thermometer?
Could be both.
Could be both. All right, so now you know the difference. And yes, Chloe, a clock is definitely a measuring tool. Now I'm gonna take a measurement, an example, and call out for Marianne. Marianne, let's talk about my neighbor. My neighbor measured his mass this morning and it was 68.2 kilograms. He told me this, probably he's lying, I don't know. Let's discuss the error on this measurement. By definition, the error is the smallest reading. By the way, I'm using a digital measuring tool. All right, so this all applies for a digital measuring tool. So back to you, Marianne. Let me change the font to smaller font, probably 20. All right, so digital measuring tool, the measurement is 61.2 kilogram. We need the error, which is the smallest reading. What is the smallest reading we can read using this measuring tool? Can you guess? He said everything on the screen. I told him, please tell me everything you see on the screen. He said 68.2. So what is the smallest reading the screen can give me? Marianne. Probably Roy can answer. Okay, so Elias said 100 grams. He meant 0.1 kilogram, right? It's the same thing. So can you speak up and tell me why you believe 0.1 kilogram is the answer for the smallest reading? Anyone else? Probably Roy? Yeah, so basically you guys, because 0.2 was the last digit. All right, so basically since 0.2 is the last, this is the last digit, the smallest I can read on this screen is 0.1. If I need a better precision or a worse precision, I need to throw the bathroom scale and get another one. So this is the precision of the bathroom scale that my neighbor actually has. Probably mine would give me more decimals. So it depends on the bathroom scale. And let me stress on the fact that this is digital. All right, now we're going to take an example of an analog measurement, and probably talk to Roy about it. Yes?
Can you just repeat the idea of digital and analog measurements?
All right, Kausar, simple. A digital measuring tool is a measuring tool that has a screen. You simply read what's on the screen. All right, anything that has a screen and it gives you digits, it's a digital measuring tool. Analog, it could have a screen, but no digits, probably a needle instead. A ruler, a cup, you have to estimate. And estimation doesn't have to be low precision, but you need to read between the graduations. That's analog. So needle, graduations, all this is analog. Digital is when you have a screen and you have digits written on like 1, 2, 3 decimal, you know, fine. And the rule states every time we have a measurement on a digital measuring tool, the error is the smallest reading. So we say the error is plus or minus 0.1 for this case. Now we're gonna tackle an analog measuring tool, and I want Roy to help me with that. Let me go back to font 20. Roy, I want you please to measure the length of the red line. Can you do it for me? Sorry.
Yes.
Okay, so yes, what do you think?
It's around 2.3 centimeters.
Okay, 2.3 centimeters. I love that. Thank you for giving me a unit. Now let's write the error. The error on it is the smallest subdivision divided by 2. Divided by 2. Let me remove the chats. Okay, so smallest subdivision divided by 2. Smallest subdivision by definition is the smallest jump, يعني whole. What is the smallest jump? See it?
Is it 0.15
Unit, please.
centimeters?
And why do you say 15? So this is 0.15, this is another 0.15, this is another 0.15. So you'll end up with, I don't know.
So is it 0.05? Because it's the smallest subdivision is 0.1.
All right, so you see that the smallest subdivision is 0.1 centimeter. Half of it is 0.05.
0.04.
I do agree.
Centimeters.
Yeah, I do agree. Anybody disagree with us? All right, so it's very important to say centimeters because a lot of students would want to answer millimeter. So just make sure we agree on the unit. All right, now I want you to look in here. The error states that it's 2 decimals, which means you are supposed to answer the initial length 2 decimals. So Roy, when you said 2.3, were you sure about the 3? Obviously, yes, because it's 3 and something. Can you guess what is the something extra? I know it could be a random guess. Can we say 2.3 and can you add a digit? Because,
yes.
Yeah, can you add a digit?
32.
Okay, probably Jana will not agree with you and it's okay. The last digit is always an estimation. So don't say 2.3 because when you say 2.3, you're telling your audience that it could fluctuate between 2.4 and 2.2, which is not the case. It is actually fluctuating between 2.34, probably 2.31, you know? So the 3 we're very sure about. Don't let it be your last digit. How do I know? I always look at my uncertainty. If my uncertainty is 2 decimals, my answer is allowed to be 2 decimals as well. And it's okay if we estimate the last one. It's totally fine. And if you don't agree with your partner, it's totally fine. Remember, you're still within the margin of error. Make sense?
Okay.
A bit. So now let us try probably to list the rules. But before listing the rules, let me show you something. We're talking here about instrumental errors, by the way, not the personal errors, not the natural errors yet. I want to show you 2 different rulers, actually 4 different rulers of different uncertainty. You see, this is a regular ruler, the one in here. So you see the smallest subdivision is 0.1 centimeters. Here you have inches. And you see the smallest subdivision is different. Here you have feet. Here you have inches. And you can see the smallest subdivision for this guy is different than this guy because every subdivision here is divided by 2. So on the market and the bookstores, you can find different rulers. I remember when I was back in high school, I had to buy a ruler where the millimeter is divided by 2. Have you ever been asked to do so in high school? Find a ruler in a bookstore where the millimeter is divided by 2 to be able to give measurements with higher precisions and probably 3 decimals instead of 2. Yeah, when I was back in high school, I had to buy this. It was a trend for the French back. Not anymore, probably because now they use more sensors or something like that. So analog is not the trend anymore. All right, back to the rule. Uncertainties. Every time you write an uncertainty, and those are 2 different examples we did. So this is digital and this is analog. For the digital, the rule is you take the smallest reading. For the analog, you take the smallest subdivision divided by 2. But whatever you do, make sure the uncertainty is 1 sig fig. So let's say you got 0.5 as the smallest subdivision. Half of it is 0.25, stated as 0.2. Don't give 2 digits for the uncertainty because 1 digit is allowed to fluctuate only. Make sure you add the unit. You have to agree centimeter or millimeter, otherwise it's going to be confusing. And make sure the number of decimals do actually match, like in this case, where the error 2 decimals, and the measurement should be 2 decimals as well. This is 1 decimal, this is 1 decimal. Otherwise, fix your initial measurement for it to be similar to the uncertainty. The uncertainty tells me about precision. And since I know what the precision is, I can make sure my measurement has the same precision. Okay? I'm going to repeat those rules every now and then for you to remember. 1, 2, and 3. Okay? Uncertainty, 1 sig fig, add a unit, round your value according to the number of decimals of the uncertainty. Now this, I want to ask Carl. Carl, my question for you is that measuring tool analog or digital? Carl?
Yes, I didn't get the question.
All right, the measuring tool here is a ruler, analog or digital?
Okay, it is analog.
All right, this case, analog or digital?
I can see where you're pointing.
Okay, this. Probably
maybe my screen is lagging.
frozen. Okay, I'm talking about the bathroom scale that is white.
Yeah, I can see it now. It's digital.
Okay, and here I'm talking about the thermometer. Is it analog or digital?
It's analog.
All right. If I give you this example to try on your own, if I ask you to do the measurement and write the uncertainty, measurement plus uncertainty, measurement plus uncertainty, following the rule that the uncertainty is the smallest subdivision divided by 2 for the analog, and it's the smallest subdivision or the smallest measurement for the digital. Do you know how to do this?
Yes.
Okay, I want you to try. I'm going to give you a week to try and we can discuss the answers later. So this is for you to try on your own for next week, okay? You can take a screenshot or wait for me in the evening. I can send you all the screenshots you want. All right, now we're ready to start averages. Let me go back to the outline. So we already did this and this. Now we're doing averages, okay? Romy, I need your help. As you can see, this guy is measuring his mass and this guy looks so angry. I have no idea why. Can you tell me why do we have to do an average? And why do you believe this guy is taking the measurement over and over again?
He took 3 measurements because he thinks that the first one wasn't precise enough.
All right, so he's taking many measurements to increase precision. These are 3 trials. What is the definition of a trial? Any 3 measurements could be trials?
If they were in the same conditions, yes.
All right, this is very important. Same conditions, same exact experiment for us to do the average. Romy, I suppose you have a calculator. Can you find the average of this guy, of those measurements? And please tell me the answer. Everyone can do the calculation with Romy, so you can give confidence to Romy. So we're finding the average. How do you calculate the average, by the way?
It's the sum of the 3 values divided by the number of the values divided by 3.
Okay, so you add them up divided by 3. What is your answer,
Yes.
Romy, for this?
89.3.
The calculator gave you only 1 decimal, right?
Yes.
Unit, please.
Kilograms.
Kilograms. Okay. Now check the equation. To find the average, we do sigma values. In other words, we add the values and then we divide by n. N is the number of measurements, and this is what you did. I'm gonna call it M bar. M bar stands for average, so M bar. Cool. Now we're gonna find the error on the average. For my DP students in high school, for them to find the error on an average, usually they find the range, which is the difference between the smallest value and the biggest value, divided by 2 to find the error. But that's not a very precise method. In your case, you're gonna find the RMS error. RMS error is very similar, very close to the idea of standard deviation, but it's not a standard deviation. We're doing root mean square, which shows me how much scattering is happening around the average, all right? How far away the measurements are away from the average. And to be able to do so, we're gonna use this equation, alpha RMS, it's gonna be sigma di squared over n into n minus 1. N is the number of measurements, which is 3 in this case. So 3 times 2. What is sigma di squared? Let me write it here in an expanded form. Okay, it is actually d1 squared. My keyboard is dying for today. d2 squared and so on. Okay, now we need a definition of d. Anybody understands what we mean by D?
Difference between the measurement and the mean?
Yes, we call it deviation.
Absolute value.
Deviation.
Yeah, I don't really care about absolute value because I'm gonna square it anyway, but yes, we usually take the absolute value. So D is called the deviation or the difference. Somebody was talking, I did not hear you, but yeah, this is the main idea. So D1 is gonna be M1 minus M bar. Okay, and you're gonna calculate D1, D2, D3, then square each. You call it dispersion as well? I never heard of dispersion under this idea. Probably dispersion can mean something else. I know it's called either difference or deviation. All right, dispersion probably would mean something else, and I don't want to go there. So, and then you're gonna square each and then add them up. All right. Can you try to do the work, Romy? Is it a lot to ask? Let me take a screenshot. I know it's time consuming, that's why. I'm gonna take a screenshot of this one so we can keep it on our slide. Romy is gonna do the calculation for alpha RMS and everyone else is gonna help Romy, please, and give me an answer. And this is the screenshot to keep next to us. Yes, an answer for the RMS. I'm gonna be quiet for 1 minute. And don't forget the error should be 1 sig fig. So give me a rounded answer. Do the rounding to 1 sig fig. Maria, I see you. Let's wait for the others. I'm gonna get more water, but I'm close. I can see no answers. We'll wait more. 0.3 for Romy. Romy, the calculator gave you 0.3 or you did the rounding?
No, the calculator gave me 0.29.
All right. Are you sure you did the radical for the whole thing?
Yes, I did it on the calculator. I put the data on the calculator and I did the standard deviation.
All right, be careful. Standard deviation is not this one. This is the RMS. You still need to divide by radical n for it to become alpha RMS. And let me write it for you. Oops. Okay. So if I do this, I will have more space. So alpha RMS, if you already know how to find the standard deviation, look at you, you're so bright. It's the standard deviation, whatever you want to call it. I'm going to call it STD divided by radical n. Because the STD is actually the whole thing without the n. Or am I wrong? Yeah, I think so. So if you do this, Romy, what would be your answer? Yes, so it's going to be 0.2.
Yes, it worked.
Yeah, 0.2 unit. Kilograms. So I'm back to this. I'm gonna say the uncertainty must be 1 sig fig. 0.2 is 1 sig fig. We just added a unit. Thank you, Kausar, for that as well. It's kilograms. Now we're gonna check the uncertainty and the average. Do they have the same number of decimals? They do. 89.3 and 0.2. Perfect. I have the value and the RMS. Otherwise, I need to round M bar or add zeros to just state to my audience how precise my average is, because the alpha RMS is the one that would dictate how precise the average is. All right? Okay, I have some good news for you. You will not use this equation anymore because this equation is time consuming. I just wanted you to make sense out of the different parameters or different identities inside this equation. Please never use it again. It's time consuming. You can simply watch this YouTube video. I did this demonstration for you using my own calculator, and I think Romy was using the same method, and probably you already know how to use it or not. We can watch the video now, but no need to waste your time. So you can watch it on your own. Make sure you have the same calculator. This is a regular Casio. If your calculator is different, please let me know immediately so we can sit and see how we can do the alpha RMS on your calculator. Okay, so please learn how to do it on your own calculator. For now, how about you do calculator and equation together for you to make sure you get the same answer and be confident about how to use your calculator, okay? So I urge you to visit this link, check it out. I'm just recording myself doing it on the calculator. Now, do you think you can do this on your own? You are given different temperatures, and you need to find the average and the error and do all the rounding following those rules. All right, yes, if you can do that, take a screenshot or wait for me to upload this on Blackboard. That's your assignment for next week. No, it's not graded, and yes, it's not optional. All right, I'm ready to start with the calculated value. Do you feel overwhelmed already, or are you fine?
Do we have to submit the assignment or just
Yes, I want you to submit the assignment. I'm going to check them. I'm going to give you an answer key or probably discuss the answers in class. It's not graded, but I want you to take some time to see how Blackboard is, to try to submit something, even if it's not graded. So whenever the time comes and you want to submit something, you will be familiar with the whole thing. All right, is this PowerPoint is gonna be on Blackboard? Of course, Kausar, I'm gonna give you the edited PowerPoint, the one with my handwriting on. If you do mind and you want the original one, of course, I can give you the original one as well. All right, so now you need to calculate F, okay? And you're gonna use this law. Anybody remembers the name of this law? The famous F equals ma. What is this law? Newton's second law. Thank you, Roy. Newton is my favorite, by the way. So A is the acceleration, M is the mass. A and M were measured. I have no idea how the measurement was done. Probably calculated, probably measured with a digital measuring tool, probably measured with an analog measuring tool. Somebody did the work, not me. Probably my neighbor, probably my lab partner. But I can see this is 1 sig fig. The rounding is perfect. I can see unit and I trust those values. So those are given to me. The question now, find F. Let me see. I did not talk to Marilyn today and to Emilio. So let me start with Emilio. Emilio, can you please help out finding F? I need to calculate F. How do we calculate F? Simple. Grab a calculator. Yes, Emilio? Yes, so basically, Chloe, you will have the assignment of significant figure, the assignment of averages, the assignment of calculated. So you will be given 3 slides. Let me show you. This is the assignment I'm gonna post. 1 second. It would be slide 1, slide 2, slide 3, and slide 4. So 4 slides. I forgot the measurement one. Okay, so 4 different slides. If you can wait a bit, I'm gonna post it in a while. All right, so they are 4 very simple slides, direct application, just for you to check out your list if you understood or not. Okay, so back to Emilio. Probably Emilio is not with us, which means Marilyn can help me now. Yes, Marilyn. So the question is calculate F. How do you do it?
Can you hear me? I don't know if my mic is working.
All right, are you Emilio?
Yes, I am.
Okay, great, Emilio. Marilyn, give me a second with Emilio. We need to find the F. We are given A, we are given M. How do you find F?
Okay, we do F equals M times A, so 15.8 times 2.2.
Okay.
And we get 54.76.
Okay, you can give me any number of sig figs, it's okay, because we're gonna round later. Tell me again, what is it? 58? 50?
34.76.
34.76. Can you help me with the unit?
For
Unit?
it's Newton.
All right, so this is the value of F. Thank you so much, Emilio. Now, back to Marilyn. Marilyn, we need to find the uncertainty on F. I know I have an uncertainty on A. I have an uncertainty on M. This uncertainty will propagate to F, and the uncertainty of this one will propagate to F. It's a function, and I need to do propagation of errors to find the error on F. Do you have an idea how to do this? Probably you did this previously, probably not. Can you guess a method, Marilyn? Yes? Do you hear Reem? She's fighting with her dad. Okay, Marilyn, probably am I glitching and you cannot hear me? I don't know. Karen can help us as well. Karen? I need Karen, please.
Yes, here, doctor.
All right. So Karen, we need to find the error on F, right? Do you have an idea how to do the work?
I don't actually.
All right.
Maybe you could try to, it could be the product of the uncertainty. I don't know.
Some people would say that. Actually, no, we cannot do that. I think Kausar has an idea. Yes, Kausar, you can try.
We do the square root of the uncertainty of the first 0.1 over the 2.2, the value of A, squared, we square it, plus the same thing for the mass, times the answer we got for F.
All right, so basically this is fractional uncertainty for A and M, like the Pythagorean theorem, squared plus squared is equal to the squared of the fractional uncertainty. Where did you learn to do this? In high school or in some other lab?
No, in another lab.
Okay, your method, Kausar, is right. Can you use it for multiplication and division?
Yes, both.
Can you use it for plus and minus?
No, it's another method.
Okay.
Plus and minus.
Okay, do you have a method for radical or for sine and cosine?
Actually, no.
All right, so basically Kausar just stated a method also called propagation of error that could only be applicable for multiplication and division. She learned this method in chemistry lab. She also know another method for plus and minus, also from chemistry lab. By the way, the DP students actually, I mean the IB students use this method, and I don't see why not. You can use it, Kausar. Personally, I need to give you a very general method that would work for any function. The function multiplication, the function where you have a square, square root, cosine, sine, exponential, logarithm. It's a general propagation of error. I need to warn you that the equation looks horrible. I don't want you to freak out. We can break it down and translate it into simple words, okay? So please don't freak out. This is the equation. What does it mean? Stay with me. This is the derivative of f. Some people call it f prime. Now f prime is easy to do. This is another derivative of f. And this is another derivative of f. The thing is that f has many variables. X, Y, and Z. In your case, it's only M and A. So we do not need a third derivative. So you're gonna take M to be your variable, do the derivative. Take A to be your variable, do the derivative again. This is the error on A, and this is the error on M by order. And eventually, very similar to Kausar's method, you will do the squared, add them, then you do the square root like the Pythagorean theorem. Now the challenge is how to do the derivative. But since you guys are fresh graduates, probably you can still remember. I was talking to Karen. Now I can talk to Chloe. Chloe, can you please help me a bit with derivatives? If I have a constant, what is the derivative of a constant? Chloe.
I think it was 1 or zero. I think if it's a constant.
The derivative of a constant is 0. The derivative of constant times x, what is it?
1.
It's constant. So 2x would be 2, 3x would be 3. Okay? Derivative of cx squared.
2e.
So
2ex.
Yeah, this is cx. All right. This one you may not remember. C over x, what's the derivative?
Honestly,
you can't remember.
I don't remember.
It's negative c over x squared. You can simply, no, it's not ln yet. Ln is the antiderivative or the integral. What is the derivative of who would give me ln? I can't remember. I know that the derivative of ln is 1 over x, yeah? All right, so you can simply say c into x to the negative 1 and do the derivative like cx to the n. Anyway, we're not doing math here. This is not a math class, which means if you don't know how to do this, you come to me, I do it for you, okay? And while I do it for you, you are training yourself to remember or to learn. Okay, so now I'm gonna do the derivative of f, but I'm gonna take a to be my x. In other words, this was gonna be m times x. M is a constant. So when I take a to be my variable, everything else is a constant. Who was talking to me? Chloe. Chloe, what is the derivative of mx? X is a variable, m is a constant.
M.
Okay, this is m. Now I'm gonna do the derivative of f, but m is my variable, everything else is a constant, so it's gonna be x times a. What is the derivative of x times a? A is a constant. Yes, Marilyn, that's true. Jana, that's true. Did I lose you? I'm lagging. Okay, I'm so sorry for that. Let me put my video away for a few minutes. Yes. All right. So basically, if I do the derivative, if I take a to be my variable, put x and everything else is a constant, you do the derivative and so on and so forth. Now you just simply have to plug in the values. M is given. Error on a is this. A is given, error on M is this. Probably I can ask Hamar. Hamar, can you plug in the values of M, error on A, error on M, square both factors, add them, do the derivative, the radical, and give me a final answer for alpha F. I will give you some time. I know it may take time. Unfortunately, there's no other way. Like the calculator has to do the work for you, Amar. But you can simply put it in one shot. Everyone else can help Amar. So I'm waiting for an answer. Anyone? And Omar.
6.32.
6.32. Did you do radical of the whole thing?
Yes.
Unit, error on F. F is a force. Yeah, Newton. Okay, anyone has a different answer for error on F? You got 1.8. I remember I got something very close to 2. So probably my answer is closer to Kausar. Can you check again, Omar? Romy got 1.8 as well. More confidence for Romy and Kausar. Probably you forgot to square something or to do the radical or anything.
No, I don't know.
All right, let me write it for you. Basically, it's M, which means 15.8, times error on A, which is 0.1. Okay, all this is gonna be squared. Okay. Did you mix?
0.4.
Yeah, you mixed the Okay, continue. So be careful when you take A to be your variable, you multiply by the error on A and not the opposite. All right, so it's gonna be 1.8. Keep on trying, Omar. So I'm gonna write the error on F to be 1.8, and then I'm gonna jump to the rules and talk to Maria Teresa. Maria Teresa, if I jump back to the rules, it says uncertainties must be 1 sig fig, add a unit, matching for the decimals. Back to my values. 1 sig fig, help me, Maria Teresa. 1.8, please round to 1 sig fig.
2.
2, add a unit. So 2, add a unit. What's the unit for
Newton.
error on F? Newton's already written by Omar. Now decimals. This is how many decimals?
None.
No decimals. Please fix your measurement to no decimals.
35.
Exactly. So my answer is going to be 35 plus or minus 2, and all of it is newtons. All right. So we just learned how to calculate F and how to use propagation of error to find the error on F. And we have to follow the 3 steps: round the error to 1 sig fig, add a unit, and then match the number of decimals. So now your job is to try this on your own. The question is to find R, and I mean by that you need to find R along with the error on R. Okay, you are given U. By the way, U equals RI is Ohm's law. In other words, R is gonna be U over I. So you have division in here. If you don't know how to do the derivative, please throw me an email, ask to meet with me, ask on the chat, anything, or do your own research on how to do the derivatives to simply remember. All right, you are given U along with the error on it, and you are given I along with the error on it. Be careful, it's in milliamperes, so probably convert to amperes first for you to end up with resistance in ohms. Can you try this on your own? The deadline is next time I see you, so it's gonna be Monday evening because I'm gonna see you on Tuesday. Is that cool? Is that it for today? And that's it for today. Next time I see you, by the way, next time is not going to be next Tuesday. Even if the deadline is 1 week, I don't want to delay the deadline more because you're going to forget all that. Next time I see you, we need to start experiment 1 according to schedule and continue a bit through our outline, because as you can see, we still have item 5 and 6 to cover. I'm going to update the outline. 5 and 6, they're related to graph skills and slope and error on the slope. I'm not in a hurry. I need to take my time. I need you to grasp this very well, okay? And every experiment you do, you will have to use this and that and this and this and this and this in each and every experiment we do. Probably not all of them, but most of them. So that's why you guys are getting ready with a good package of data analysis. Any question before I leave you? I'm gonna stop recording.